Okay, so section 3.7, to give you a little bit of context for what we're going to be doing here, we started off when we were talking about data sets. We wanted to understand sort of how to understand a lot of data all at once. We started by looking at the measures of center, so we could see, all right, where's the middle of the data set? And we had the three different ways of measuring where the center is. And then we looked at measures of spread, right, in particular the standard deviation. We said, okay, this is going to give us a way to measure how spread out the data is from the center to help give us a little bit more information, particularly about big data sets. What we're going to look at today is ranking or position. That's going to tell us where data points are within a data set, like where are the data points relative to all of the other data points. Okay, so that's what we're going to do today. And the first thing we're going to look at is something called percentile. Okay, so percentile is a measure of ranking, and it measures where a data point is in the data set relative to everything else. Okay, so first let's talk about what it is, and then we'll look at what that means a little bit. So the kth percentile is the data value that has k% of the data at or below that value. So for example, if we say maybe you take a standardized test and you're in the 90th percentile, what does that mean? Okay, a score in the 90th percentile means that your score is at or above 90% of the other scores. So 90% of all the scores are at or below the score. Okay. Or another way to think about that is a person did the same as or better than 90% of the other test takers. Okay, so when we say like the same as or better, we can typically think of just better, but it gives us a way to deal with like ties. So that we're not ambiguous there. So what does a score of the 70th percentile mean, right? So if a score is the 70th percentile, that means that 70% of the scores were at or below this score. Okay. All right. So now let's look at how this is useful. So in this next example, let's suppose we take a test that's out of 100 points, and we scored in the 80th percentile. What was your score on the test? Okay, there's not enough information to know here. Okay, the 80th percentile doesn't mean that you scored 80% on the test. What it means is that you did as good as or better than 80% of the other test takers. So if everyone got an A on the test, then 80th percentile would be somewhere in the 90s. If everyone failed the test, maybe that 80th percentile would be somewhere in the 50s. So this isn't enough information to know what your actual score is. Okay, so we don't know how what this score is by just knowing a percentile. Okay. So all we know is that you scored better than 80% of the other test takers. Okay. Better than or equal to. Remember, ties count. Okay, but we're not going to get too hung up on that. Okay. So we don't know if that's a low score or a high score. We just know that it's It's better than most of the other people. All right. We're going to give a special name to some of our percentiles, and we're going to call them quartiles. A quartile, think of the word quarter, right? Quartiles is just dividing things up into quarters. So the first quartile is just 1/4 or 25%. Okay, so so just maybe a little bit of terminology. Okay. The first quartile which we'll just write as Q1, is just the 25th percentile. Okay. All right. The second quartile is Q2, which is also the median, which is also the 50th percentile. Okay. The third quartile, we'll often just write as Q3 for short, is the 75th percentile. See, it's going up by quarters, right? 1/4, 2/4, 3/4. Okay. The fourth quartile we don't ever really use because it would be the 100th percentile. So it'd say that all scores are below 100% of scores are below this score. So that's just the highest score. Okay. So we don't typically use the fourth quartile. Okay, because that would just be the highest score. Or the highest value in the data set. Okay, so if I want to find the quartiles, an easy way to do this is to first find the median, right? So if I list my data in ascending order, right, or increasing order, cut it in half. That halfway point is the median, so that's my second quartile. Okay. Then for each of the two halves, find the median, and that will give me the first and third quartile, right? Because halfway through the first half is 25%, right? Halfway through the second half is 75%. Okay, so if I want to think visually about this, if I have some data set on a number line, okay, just put a bunch of data values on here. Put them as like little X's. Okay. So there's the median. There's the third quartile. There's the first quartile, right? So you just say, okay, I'm going to start by chopping my data set in half, right? There's 7 data points, so 3 on each side would mean that this guy here is the middle. Okay. And then out of the first half, I take the middle value, that's the first quartile, and out of the second half, I take the middle value, that's the third quartile. Right? Okay. All right, if I also consider the lowest data value, right? So this is the minimum, or smallest data value, and I consider the highest data value, okay? These 5 numbers give me kind of an accurate idea for how the data is spread out in my data set. Now, if I only wrote down 7 numbers, 5 numbers isn't really much of a summary, okay? Remember, the idea here is to describe bigger data sets. But this is what the 5-number summary sort of looks like visually, okay? But I can just take the min, the quartiles, and the max, and that gives me sort of an idea for what the whole data set looks like, or how spread out it is. Okay, so if I can see, the min and Q1 are close to the median, I can see that data is clumped up over here on the left, but maybe it's spread out further on the right. Okay, that would be an example of how it gives me some information. Okay. So we're going to define one more thing and then go through a couple examples. When I look at this visually, okay, in between the first quartile and the third quartile, right, to go from the 25th percent to 75th percent, that's half of the data. So let me sort of mark this on here. This is half the data. And in particular, it's the middle half. Okay. So if we know how wide that middle half of the data is, that gives me sort of a good benchmark for the amount of spread outness of the data. Okay. And so we're going to give this a name, and we call this the interquartile range. Right. So the interquartile range, which we're going to just abbreviate IQR for short. Okay. Here's my formula for it, right? It's just Q3 minus Q1. Or a way to think about it is it's the range. Okay, remember, range is the difference between the max and the min. Well, this is the range for the middle 50% of the data. Okay, so if that interquartile range is small, then I know that the middle chunk of my data is very tightly packed. If the interquartile range is large, I know that my data is very spread out. Okay. The interquartile range is useful for determining outliers because when we talk about the middle 50%, that is, of course, not going to include any outliers. Outliers are like away from all the other data points. The middle 50% are they're part of the middle, right? So, but it gives us sort of a distance measurement for how the data is spread out that doesn't include outliers, and so we can use it to measure how far away a potential outlier is. Okay. So I'm going to give you a formula here for determining what an outlier is, but what I want to do immediately afterwards is show you how to use your calculator to find outliers, okay? So that we don't get buried in formulas here, okay? So here's our formula. So this is just kind of giving you an idea for how this is computed and how your calculator does it. So what we're going to do is we're going to create these fences. And what we're going to do is say, all right, the lower fence, okay, is just Q1 minus 1.5 times the IQR. Okay. The upper fence is Q3 plus 1.5 times the IQR. And what I'm going to do is I want to show you what this looks like visually, so that you can kind of see what this means, what we're talking about here. All right. To do this visually, what I want to do is also show you how to get some of this stuff onto your calculator. Okay. So what we're going to do is we're going to look at a data set, and we're going to put it into our calculator and have it compute all of this stuff for us. The whole 5-number summary, right? All the quartiles and everything. And also have it determine whether something is an outlier. Okay. So first, let's look at the 5-number summary. In order to make a 5-number summary, our calculator, the steps are exactly the same as we had before when we were computing mean and standard deviation. Okay, it's all on that same screen. So we push stat, we hit 1 to enter the data into a list, and then we hit stat again, go over to calculate, and hit that one variable statistics. And that's going to, when we hit calculate there, it's going to show us all of our information that we're looking at. So let me pull up our calculator. Okay, and let's look at a data set. So I'm gonna skip a little bit and come back here. So let me get to a data set. So here's our example. Total assets in billions of Australian dollars of Australian banks for the year 2012 are given in this table. Okay, and let's just compute some stuff. Let's find the 5-number summary and so on. Okay. Before we get to that, the first thing that we should always do when we're looking at a problem is make sure that we understand the context. So we want to identify what is an object, what is the variable that we're talking about, what type of variable is it. Okay. So if I look at what is an individual object, what is the thing I'm looking at to collect data from, okay, it's an Australian bank. Okay. What is the variable, right, or the piece of information that we're recording, right? It says that we are looking at total assets. Okay, and this is measured in billions of Australian dollars. Okay, what type of variable is that? Well, I can look at the data and I can see that these are numbers, so this is going to be numeric. Okay, right? Or we could just say, oh, okay, if I'm measuring assets in billions of dollars, again, that's numeric data. So this is quantitative. Okay. So what I'm going to do now is I'm going to enter all of that data into my calculator, right? So I'm going to hit Stat, I'm going to hit Edit, and we're going to type these in. Okay, so I have my 12 data points in. If I want to now compute things like the mean, median, mode, quartiles, okay, all of that stuff, I go to Stat, go over to the Calculate menu. The first thing on here is one variable statistics. I hit Enter. My list is L1, so we're good to go. I hit Calculate. Okay, starting at the top is things that we're not looking for right now, but it tells me the mean and the standard deviation. And when I scroll down, I can see, okay, here's my full 5-number summary. I get the minimum value, first quartile, median, third quartile, max. Okay. So it's a really easy way to get, all of that information. I don't have to, manually find stuff. Just to look at what this would look like without a calculator if I wanted to do this. And the point here isn't to figure out how to do things without a calculator, because that's helpful. The point is to understand, well, how does this fit together, instead of just thinking of your calculator as this, magic box. So what is it doing? So what we could do is we could say, well, start by listing all of the data in numeric order, right, in ascending order. Okay. And then in order to find the median, I'm going to find the halfway point, right? So if I count how many values I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so if I have 6 on each side, right, that gives me the middle. And we said, well, we want one middle number. Because we don't have one middle number, we have 2. The median is going to be the average of these 2. So I'm going to take 2964 and 2965 and average them. So I get 2964.5. Okay. Which is what my calculator computed. Okay, now when I write it down, though, we want to make sure that we keep our units. So this is a billion. Oops. Oops. Billion, Australian, AU for Australian, and D for dollars. Okay. All right. To find the first quartile, if I now look at this left half, okay, I find the median there. So you could think of it like as its own data set and say, okay, if I had these 6 values, the median would be right in the middle. So I'm going to average these two guys. So the median here would be 2862 plus 2884 divided by 2, because again, we have this even number so that we have to average them. So I get 2873. Okay, so that tells me that that's the first quartile. Okay, and likewise, if I look at the top half of the data set, okay, I can think of that as being its own data set. And then I find the median of that data set. And we say, okay, here's the median. Again, I have to average these two values. Okay, 2971 plus 3002 divided by 2. I don't want to actually pull up my calculator and do that because I want to keep those other numbers on the screen. Okay, but I should get 2986.5. Okay, so that's going to be my third quartile. Okay. And again, that lines up with exactly what I get on my calculator. There's the 2986.5, and for Q1, 2873. Okay. So your calculator is doing the same process that we were learning by hand. Okay, same numbers, so you don't have to worry about it. So then, if I wanted to write down my 5-number summary, by hand, okay. So my minimum value, if I wrote things in order, the minimum value is just going to be the first one on the list, right? So that's 2855. Then I write Q1, and I write the median. Then I write Q3, computed at 2986.5, and then I write the max. That's the biggest data value, so 3032. Okay, so that's how to do things by hand and how to get them on your calculator. Okay, now let's look at this visually. So to get a nice visual of this, we're going to do something, we're going to create a graph called a box plot. Okay. So let me first show you what a box plot is. The box plot is just kind of giving you a graph of this 5-number summary. Okay. So what we do is we put, our minimum value on here. Okay. Then we put a box around our middle 50% of the data. So the first edge of the box is Q1, and the other edge of the box is Q3, where we put a bar in the middle at the median. Okay, and then we have a dot over here for the max. Okay, so this is on a number line, so that gives you a sense of scale, right? So not everything is equally spaced apart. These 5 numbers are not equal distance apart. Okay. And then my notes here say the distribution is skewed right because the right tail is longer, but I don't think that's true. I mean, look at it. Seems like it stretches further to the left. We'll come back to that. We'll look at that. Let's look at how to create this box plot. Okay. If I already have my data in the calculator and I want to create a graph, what we did before is we said if I hit stat plot, that's how we can create histograms. This is also how we create box plots. Okay. So just go to the first one, make sure it's turned on. And instead of selecting the histogram, which you've probably done in the past, what we're going to do is select the one that looks like a box plot. Now it's tricky because I have two different things on here that look like a box plot. For this class, we're always going to want to pick this first one that has the box plot. Let me move my cursor over, with the separate dots on the side. Okay, and the reason for that is because that's going to be the box plot that shows us outliers. The other type of box plot doesn't mark outliers. Okay, we want the one that does. So I select that. My X list is L1. I say great. I hit graph. Nothing shows up on the screen. That's normal. What I need to do is readjust my zoom window, right? So I hit zoom, and I either go down to number 9 or just press number 9 for zoom stat, and it will realign my zoom window. Now, unlike a histogram, I don't have to mess around with anything to get this to look right. This is what my box plot looks like, and I'm good to go right here. I don't have to make any, crazy adjustments. And if I hit trace, it will tell me that 5-number summary. There's the min, Q1, median, Q3, and the max. So it tells me what the numbers are, and it gives me a visual of where they are. Okay, so that gives us kind of a handy connection, and it makes it a little bit easier to, understand, the graph versus the numbers, right? It's all kind of nice here, contained on the screen here. Okay, and here's those steps written out. All right. So let's go ahead and look at another example, starting fresh. So I want you to go ahead and try this out. What we're going to do, well, let's read through the problem. Life expectancy for a person living in one of 11 countries in the region of Southeast Asia, 2012, is given below. Find the 5-number summary for the data and the IQR, okay, and then draw a box plot or a box and whiskers plot. Okay, and what I want to do is start by identifying the object, variable, and type of variable. Okay, so I'll do that with you, right? And then I'll give you a second to go through the rest, right? So the object, if I'm looking at the things that we're picking, this says the life expectancy for a person living in one of 11 countries. Okay, so these are life expectancies for a country. So my object is going to be a country in Southeast Asia. Okay, and the variable, or the piece of information that we're collecting, is the life expectancy. Okay, and that's a numeric variable or quantitative. Okay. So now I'm gonna pause here for a sec and give you a second to see if you can compute the 5-number summary and then draw a box plot. So remember, when you go to type in new data, you want to make sure that you've erased all of the old data. And the two easy ways that we had to do that, you can just hit delete over and over again until everything is done. Or if it's a bunch and you don't want to hit delete that many times, if you hit up so that you're selecting the whole list at once, you can hit clear and then hit enter, and that wipes it out. Okay. So we have these 11 data points. I put the data in my calculator to compute the 5-number summary. I can hit Stat, go over to Calculate, one variable statistics. Okay, there's no frequency. Make sure that's blank. Hit Calculate. Okay, and down here at the bottom is my 5-number summary. Okay. So we'll just go ahead and write these down. Well, we'll do this at the top. Okay, so my min was 64. Q1 was 65. We had 69, 74, 77. Okay, so here's our 5-number summary. Then if I want to get the box plot, I can go and hit stat plot, but my stat plot is actually already set up. Okay, so I can hit graph, or I can just skip straight to hitting zoom. Stat zoom is number 9, and there's my box plot. Okay, and you can trace along and see that it has my 5-number summary. That is the data that I want to be looking at. Okay, it's not my old box plot, that's my new one. So that's what it looks like. Maybe just for one more example, I'll show you what this process looks like if you were to do things by hand. And I think maybe it helps to see that just so you can see how all the pieces fit together. So the first thing that we do, I have my table written in numerical order, right? Ascending order. So lowest value 64 going up. Okay. And what we're going to do is start by finding the median. So I want the halfway point. Since there are 11 things here, I get one number that's the median. Right, 69. And then when I go to look at the top and bottom half, since this guy's the median, it doesn't count as part of the top half or the bottom half. So I just have these 5 numbers, right, as my bottom half of the data. So the middle one is the middle number, 65. So that's Q1. And then likewise for the top half of the data, since it's an odd number, the median is the middle number, so that's Q3. Right? The lowest value is the min, the highest value is the max. Okay, so once we had this written in numerical order, finding this by hand wasn't really difficult either, but I encourage you to use your calculator. That way when you have like an even number of stuff, you don't have to worry about finding averages and stuff. It just makes everything a little bit smoother. Okay. The interquartile range, remember we said was the distance from Q1 to Q3. So this distance here is the interquartile range. So if I take Q3, 74, and Q1, 65, and I subtract them, I get 9. Remember the units here, we're measuring life expectancy in years. Okay. So that's my interquartile range, right? That's the range or that distance that spans the middle half of the data. Okay, so if I wanted to determine if something was an outlier, what we said much earlier was that we can create these fences based on the interquartile range. Oh, I did this. Okay, so what I want to do is I want to look at this box plot that we have written, and I want to see if I can compute those fences to see how far would something need to be away in order to be an outlier. Okay. So first, if I describe the shape of the data, it does look, this one definitely looks like it's skewed right a little bit, okay, but not by very much. So I would say this one is probably almost symmetric because it's not very skewed in either direction, okay. But let's go ahead and compute our fences. So let's start with the lower fence. Remember that was Q1 minus the number 1.5 times the IQR. Okay. Q1 we said was 65. And the IQR is 9. So when I compute that out, 65 minus 1.5 times 9, I get 51.5. Okay. And to compute the upper fence, that was Q3 plus 1.5 times the IQR. Okay. Which I think was 74. Yeah. So Q3 is 74 plus 1.5 times 9. That gives me 87.5. Okay, so on my number line here, 87.5 is going to be somewhere out here. Okay, 51.5 is, way to the left over here. That's how far away we need to be for something to be considered an outlier. So even if I had data values over here, those would not be considered outliers. They're not far enough away. To give you kind of a visual, this is my IQR, right? This distance. So I have to go 1.5 of these. No, didn't draw this nicely to scale. Okay, so that's 1.5 IQRs. And the same thing on the left. I take that distance and I go 1.5 to the left, right, from this Q1. And that gives me a measuring stick for how far away you are from the middle half of the data. Okay, so our measures for an outlier, I mean, they definitely seem, pretty generous, right? If you're beyond that, that seems like it's definitely an outlier. But that also gives us a sort of a consensus way to just say, all right, this is what an outlier is. We can write down, this is the cutoff point, right? If you're beyond this fence, you're an outlier. If you're not beyond the fence, you're not an outlier. And so we've eliminated the subjectivity. What I want to do now is look at what an outlier would look like on a box plot. So we're going to add a value into our box plot. So remember we had 11 values before. We're just going to add one new one to our data set. We're going to say, okay, add 32 to your data set. Okay, now I know that's going to be an outlier because I just computed the fences, and that's beyond this 51.5. But let's go ahead and see what this looks like on my calculator. So what I'm going to do is I'm going to take my data set that we had, and I'm going to go down and just add in one more value, 32. Okay, and now I want to look at the box plot, right? So I can hit graph, but I want to make sure that I re-zoom it so that I can see everything. So I hit zoom and hit zoom stat. And what it's done is it's crunched my box plot over here to the right so that it has enough space to get over to my outlier. What your box plot will do is it will mark outliers as their own separate dot. Okay, So if I were to get rid of the outlier, now it's gone again, and I look at the graph, that's gone. I didn't change my zoom window though, so that's what my box plot just normally looked like. When you add an outlier, it doesn't add it to the box plot, it just adds it as a separate dot. Okay, and that's how we want it to work. So when I'm looking at my box plot, if you have anything marked out here as separate, then you know that you have an outlier, and that's what it is. And again, if I hit trace, it'll tell me what that is. Okay, so here's my lowest value, 32, but I can also see that it's an outlier. Okay, so then the question becomes, on your box plot, what is this leftmost value if it's not the minimum value? Well, if you have outliers, you sort of don't count them for what that left end and far right end are. So this would just be the lowest value that's not an outlier. Okay, so on my calculator it says 64, and in this data set, 64 is the lowest value that's not an outlier. 32 is an outlier. Okay. Okay, so that's how box plots can tell me what outliers are. All right, so now let's move on to sort of a new idea that we're going to be using a lot going forward. Okay, so up to this point, when we talk about box plots and the 5-number summary, all of that stuff is sort of based on this idea of a median. Okay, so now what we're going to do next is look at a measure of ranking or position that's not connected to the median, it's connected to the mean. So we're going to look at something called z-score. So the z-score is a measure of how many standard deviations an x value is away from the mean. So what we're doing is we're kind of changing the way that we measure things. Instead of measuring, if we're looking at this example here, instead of measuring in billions of Australian dollars, what we would do is we change our measurement system to number of standard deviations. Okay. So our formula here could look like x minus the mean over the standard deviation. Or if we're working in a sample, our sample mean is x bar and our sample standard deviation is s. Okay, now these two formulas actually aren't equal to each other. They're just both formulas for z-score, so maybe I should write that down separately. So we would use this formula in the context of a population, and we use this formula in the context of a sample. Okay. All right, as long as you think of it as x minus the mean over the standard deviation, then we'll get the right answer either way. So let me show you an example here of not only how to compute z-score, but how to interpret what it means and what it can tell us. All right, so what we're going to do is we're going to look at two different exams. Okay, not all exams are equal difficulty, all right, as you may have noticed, in this class, but in any class, right? So let's suppose a student scores a 70 on an exam where the mean was 87 and the standard deviation was 5.7. And then later, on a different exam, same student scores 75 points on an exam where the mean was 85 and the standard deviation was 8.9. Okay, on which exam did the student score better relative to the group? Okay. So now we're not talking about just better exam score, right? Obviously a 75 is better than a 70, okay, if you're just looking at points. But we want to say relative to everyone else who took the exam, right? Relative to the rest of the class, okay? Which exam do they do better on? So what we want to do is compute their position within the data set. And since we're given the means and standard deviations, we're going to use the z-score to do that. Okay, so we're going to break this up into the earlier exam and then the later exam. Okay, and write down our given information. On the earlier exam, the student scored 70 points, so my X value is 70. Okay, the mean, all right, I'm going to use my Greek letter mu for mean, was 87. And the standard deviation, my Greek letter sigma for standard deviation, was 5.7. Okay, so if I want to compute the z-score, I take 70 minus 87 over 5.7. And when I follow that formula, I'm going to get a negative. And I think I just wrote 5.5 instead of writing 5.7. Let's fix that. Okay, so I'm going to get negative 2.98. I'm just going to round to 2 decimal places. All right, on the later exam, the student scores 75 points, so that's our X value. Okay, the mean for the exam, mu, is 85, and the standard deviation, sigma, is 8.9. Okay, so our z-score is X minus the mean over the standard deviation. So we take 75 minus 85 divided by 8.9. And when we compute that, we get a negative again, 1.12. So now what we need to do is figure out, what do these mean? Okay. Looking at my formula, if my X value is bigger than the mean, when I subtract, I'm going to get a positive. Okay. So I know that a positive z-score means that you have a value higher than the mean. A negative z-score is a value lower than the mean. Okay. Okay, so a positive z-score means X is above average. That means a negative z-score means that it's below average. Okay. So in both of these exams, we can see that this particular student is scoring below average. They would be doing better in a case where they're less below. Okay, so here, this number that's closer to 0 is closer to the average, okay, than this one. So if I were to sort of interpret these z-scores, the first exam score was 2.98 standard deviations below average. The second exam was only 1.12 standard deviations below average. Okay. So because they're getting closer to the average score, the student did better on the second exam. Okay. And in this case, that also lines up with your intuition, because the student also had a higher score on the second exam, but that doesn't always line up that way, right? You could have a lower score but do better relative to the class on a different exam if it was just a harder exam. Okay. We have to be a little bit careful, though, about what is considered better. So on an exam score, a higher number is better. But let's suppose that we were instead taking like maybe we're like running a race or something like that. In that case, you know, the winner is the person with the lowest time, right? So a lower number would be better. So everything would sort of flip, right? The you know, the negatives would be good and the positive z-scores would be bad. So it's really important that we, you know, make sure we're aware of context when we're determining what's better and what's worse. Okay. Oh yeah, and this note is really just, you know, what I was just saying there verbally. So we have to be very careful about context. All right. I think that that's it for this section. Any questions?